Okay, so on this question, they're saying Deja, it's like deja vu, Deja pilots a boat that is capable of traveling 22 knots, nautical miles per hour, in still water. She is pointing the boat due east and traveling at full speed, but there's a current moving 19 degrees north of west at 8 knots. Knots is like miles per hour, nautical miles per hour. What is the vector giving the velocity of the boat, accounting for both the boat's engine and the current? Use east for, da. All right, so basically we got to add two vectors together. So we first off have the boat vector. Come on down here. The boat vector. So whenever we do these vectors, we go m cosine of theta, m sine of theta, right? The magnitude times the cosine of the angle, magnitude times the sine of the angle. So, write that again. So what is the angle we're talking about here? Let's draw that. So I'm going to draw the angle situation. She's pointing away due east. There it is. She's pointing the boat due east. So here's north, south, east, and west. She's pointing the boat straight east. At what? At 22 knots, 22 miles an hour, nautical miles per hour. So that's easy. That's just plus 22 comma 0. I don't even need to use the fancy formulas. When they give you a vector that's right on one of the axis lines, either straight to the right or left or straight up or straight down, it's right on one of the axis lines, you don't need to mess around with the fancy formulas and use any angles. It's obvious the boat's going due east, straight to the right. So that's positive 22 on the x, right? Because this is the x and this is the y. So it's 22 to the right, nothing up. That's the boat vector. Okay. So now though, on the other side, we have the current vector. Now, current vector, again, we are gonna have to use m cos theta, comma, m sine theta. Let's draw the situation first off. This one will be a little more complex. Again, we have the north, south, east, and west. Where's the current? The current is moving 19 degrees north of west. So here's west. It's 19 degrees to the north. It's going like that direction. So let's draw that. So it's about like right there, where this is 19 degrees. Right? See what they said? It's 19 north of west. So there's west. It's 19 to the north of west. Okay, but careful. For vectors, you must use theta from 0 degrees. That's kind of from, that's right, 0, 0. So in other words, we need to know how big is that angle. There's the theta for when you do vectors. So how do you know what that is? Remember, this is like 0 degrees right here. This is 90 degrees straight up, 180 degrees right there, 270 down there. So I want to find the angle that's there. Well, how you can do that? I want that angle from 0. That's the angle you must use in a vector. Well, 180 would be all the way to there, back up 19, huh? See that? It's going to be 180 take away 19, 161 degrees. That's got to be 161 degrees because all the way to here's 180, back up 19, that's got to be 161 degrees. So then our current vector is going to be m, which is the magnitude. What is that? 8 knots. So it's 8 knots cosine 161, comma, 8 sine 161. There we go. There's the current vector. Now, we want the result now. In the boat, we want to find the velocity of the boat, accounting for both engine and current. So let's add these two together. Get a little more space for us here. Okay, so we're going to add these together. to get the result. So we've got the boat vector, which we already figured out is plus 22, comma 0 right there. And then we've got the current vector, which is a little more complex right here. 8 cosine 161 degrees, comma 8 sine 161 degrees. And then we're going to add these together to get the result. So let's do that. So I'm going to add the x with the x on my calculator. Yeah, 22. Make sure you're in degree mode. These are degree angles, not radians. So I'm getting a result here of 14.43585. I'm going to use 5 decimals. When I'm in the middle of a problem, I always use 5 decimals. The other side, I'm going to add up this and this. Well, the 0 is easy, just 8 sine 161. So that's going to be 2.60454. Is that the right answer for that first part? Oh, they didn't actually show the thing. And they kind of showed it a different way. But yeah, it's going to be the same as what they were doing. I won't confuse you or bore you with that. So that part's right. There's the resultant vector. We get the result. How many decimals do they want on this one? 3 decimals. So here, I'll go back to that. We did 14.436. 14.436. Oops, I forgot my bracket thing. They want the bracket. You notice that? So they want this. Oops, not that. That. No, not that. Let me try this again. That. Okay, well, I forgot what the number was now. 14.436. I'll go 4.3. I'll just give them more decimals. Well, 4.36. Okay. Quit messing around. The second one was 2.605 when you round it. 5, and they want that bracket thing. Let's see if they take that. Yep, that's the right answer. So so there we go. So I typed, so you just round these both to three places. Make sure you use the bracket things, comma in the middle. Okay, that's the resultant vector. Now, my question is not asking how fast, but there's other versions of this that do. So I just wanted to show you everything in one. What if they did ask on this one, how fast is the boat going? You know, considering both the engine and the current, how fast is the boat going? They didn't ask on this one, but they will on some of the other ones. So I just want to show you that. How to figure out how fast. Well, how fast is the boat going? The speed. The speed, it's the resultant vector, the result vector. Or I'm sorry, that's a dumb thing to say. It's the magnitude. It's the magnitude of the result vector. Because that's what it means, right? The result, this vector we found, we took the boat vector and the current vector, added them together, you get the result. This is the result of both the engine and the current. And if you want to know how fast it's going, you want the magnitude. You want the length of that vector. And so you know how to do magnitude, right? Remember, formula for that, square root of x squared plus y squared. Remember from the notes. So what is x? This is x. This is y. So it's 14.43585 squared plus, and what is y? 2.60454 squared. And so let's do that. And I'm getting an overall answer of 14.6689. Is that what they said up there? 14 point. Oh, I just made this up. This is number check. So there we go. That's how many knots, which is nautical miles per hour. It's how fast the boat will be going on that one. So, okay, now, final question. is at what angle is Deja being pushed north of due east? North of due east. Okay, so now we got to get our angle. How do we get the angle of a vector? Let me go up here. And don't look at that. That's a different problem. You can look at it if you want to, but it's not this problem. Let me put in, whoops, that's not the right thing. I think it's back right there. No, it's not. It's right there. There it is. There's the notes. And that tells us how we get a vector. The angle of a vector. How do you get a vector? You draw the vector, see what quadrant is, and then you find the vector doing inverse tangent of absolute value y over x, and then you do the quadrant thing. So let's do that. So let's come on down here. And I'll put a big, thick separation line here. And we're going to find the angle. So the angle, you've got to do inverse tangent of absolute value y over absolute value of x. So that's inverse tangent. So this is, again, y and x. So I'll go, it's positive. Absolute value. They're already positive, so it doesn't matter in this problem. Over positive 14.43585. Hit inverse tangent there. Inverse tangent of that. All right, that's the wrong thing. Inverse tangent of 2.60454 divided by 14.43585. Okay, and I'm getting that angle came out to be 10.22737 degrees. Now, is that the actual angle? Well, careful. Let's go back to the notes. A lot of mistakes. People stop right there. Currently, we only have the reference angle. Find the actual angle, do the quadrant. And I should have started with drawing which quadrant it's in. So which quadrant is this in? Well, if you draw a little axis system, right, with north, south, east, and west, this is a positive x and a positive y. Or you can go back here, right? They're both positive. X and y are both positive. The resultant vector, both x and y, are positive, aren't they? So that means this is going up to the right, isn't it? Because x is positive and y is positive. So this vector is in the first quadrant, 1, 2, 3, 4. Whoops. 1, 2, 3, 4. So this vector is in the first quadrant. What do you do when the vector is in the first quadrant? First quadrant, no change to reference angle. You just leave it the same. That is your angle. Now, if you were in a different quadrant, you're in the second, third, or fourth, you would have to do second 180 minus the angle, third would be 180 plus the angle, fourth would be 360 minus the angle. Remember how to do that? So you get your actual angle. So in my case, I'm getting the angle here. What is the angle? It is 10 degrees. That's from here to here. This is my 10.227 degrees, right? That's in the first quadrant right there. There's the actual angle from 0. Now, what do they want me to say? They're asking me, how far is she being pushed north of due east? Well, that's the answer then, because this is due east. How far is she being pushed north by the current? She's trying to go due east. I don't know if you remember. And the current is pushing her north of that. How much? By this angle, 10.227 degrees. Is that what the answer said? 10.227 degrees. That's how far she's being pushed north of due east. In other words, her actual angle is this is how far she's going north of due east. There we go. So let's recap real quick. How do we do this problem again? So back to the beginning. One quick recap. So they give you her boat and the current, and you just make them both into vectors. The boat was going due east at 22. That's positive 22 up 0. And then the current is 19 degrees north of west. So for that, we did 19 degrees to the north of straight west. And so whenever you do vector angles using the m cos theta, m sine theta, you got to find the actual angle from 0 degrees. How do we find that? Well, if this is 19, then 180, back up 19, This is 161 degrees. This was the angle 161. So it was 8 cosine 161, 8 sine 161, because the current was going 8 knots at that angle. So it's 8 cosine 161, 8 sine 161. So brought there's the current vector, there's the boat vector. To get the result of the current and the engine, add them together, add the x with the x, the y with the y. There's a resultant vector. They ask you on some of these problems, how fast is it? So that's the magnitude, square root of x squared plus y squared. Figure that out. And then what's the angle? For the angle, we do inverse tangent, absolute value y over x. Got this. And then you got to realize your quadrant. Ours was pretty easy this time. It was quadrant 1. How did I know which quadrant? We'll just look at x and y. X is positive, y is positive. It's right and up. So x is positive, y is positive. It's first quadrant. In the first quadrant, you don't need to change the angle at all. That is the angle from 0 just automatically. So, and that is also how far north of east, right? If she's going straight east, but she's being pushed 10 degrees north of east. So there we go.